So, as we're applying integrals, in geometry, if I had a rectangle that, let's say it was 6 by 5, right? And I have another one inside of it. Let's say it's 1 by 2. Can you calculate the area of the blue shaded region?
Yeah.
Blue area. How?
By calculating
The black area.
the full area and subtracting the little red area.
28.
Okay, good. Glad you can still subtract. I have that issue sometimes. Okay, thinking in that realm, if I give you two functions, let's call one of them f of x. And we'll call it h of x just to spite you. Okay, we can put g because that's what your book uses. I'll just Can I calculate this area?
Yeah.
Keeping in mind what I just talked about with rectangles.
Yeah.
What is it?
You take the entire thing minus the area of the cube of x.
Okay, can you put that in calculus language, please?
The integral of f of x from a to b minus the integral of g of x a to b equals area of the two curves.
There you go.
There you go.
Yep.
Wow.
So the area between f and g. It's just a subtraction problem, right?
Remember in this class, Mr. Jansen's voice
Honestly, the walls are hollow and they act like kind of like a guitar body. It just
It's so funny because when we're in that class, he sometimes like gets mad at you when you sometimes hear you. Because like we never hear you in there, and he's like, he just needs to be quiet over there. And I'm just like, you're like, we hear
You have no idea.
Yeah, we hear every day. No room.
When you play a video on test day, that's the greatest thing ever. Okay, the way that one of the easiest ways to remember this is top and bottom function, okay, and it's just top minus bottom. Okay. That's the easy way to remember it. Okay.
Does that apply if it's like under the x-axis, or is that?
This is still the area between the curves,
Oh, yeah.
right? It's always top minus bottom. Montaigne asked if the curves are under, right? It's still top minus bottom.
It doesn't matter if they're both on separate sides of the
Nope, top minus bottom. Because, I mean, just. So if I take, so think about this. This area, the top gives me the positive. The bottom will give me a negative number, right?
Right.
What happens if you subtract a negative?
You get a lot of
It adds it, right? And you get a plus sign between the two, and you get the area between the curves. Okay, so the rule top minus bottom works every time, right? Did I say that works every time?
Yeah.
So,
This only works sometimes, right?
what?
This only works sometimes, right?
No confusion in here, please.
Yeah.
Like
I've
that.
confused enough, Mason Scott.
Exactly. Thank you.
Basically covered up on.
Some of us still think we're in middle school. We don't need to be confused about calculus. Okay. Find the area of the region. This word will be used a lot in this context. Okay. between the graphs of, well, I can't pass this opportunity up. There you go. Okay, here's f of x. Make sure I do the book one. So we have x squared minus 4x plus 10 and 4x minus x squared. And our boundaries, 1 to 3.
Did you do it? Not on purpose, you should copy exactly what's in the board so you do it.
So, with that inequality statement, is that the same as just saying from 1 to 3?
Yep. So you could write from, you could do this.
Okay, I just making sure, 'cause that would confuse, that just.
The many different ways to write an interval.
I just see inequalities.
Okay. Again, my advice on these, if you're memorizing this stuff, is just
Wait, how do you know which is top and which is bottom?
write out the formula, right? So you're cycling that in your mind. That's a good question. What's top and what's bottom?
F of x is top.
Yeah.
Correct?
How do you know that?
Because first. Why?
Because there's
Multi-reasoning.
There's plus 10.
But even if the y-intercept was like at 0, was higher on fx than gx, like between the interval it could be below.
Okay, so who said y-intercept? Kyra, what's the y-intercept?
Y-intercept is how high it is.
I mean, what is it in this? 10, right? 10, okay. What's the y-intercept over here?
There's 0.
0. So which one's higher?
No.
That one,
But can it,
right?
can you have a case between 0 and 1, f of x goes below g of x? 'Cause
Yeah,
you're-
they
you're
can
not in the
cross.
interval.
We'll get to one where they actually intersect each other and cross.
So is the top and bottom rule like which one's top in the interval at the start of the interval, or which one's top at the y-intercept?
Here's what these look like. Your other clue is this is positive x squared? Negative, right? Okay, so you got some clues there. You can also do the endpoints. What's f at 1?
Seven.
1 minus 4, 7. What's f at 3?
3. Oh, that's 3.
9 minus 12. Okay, and then you can do g at 1.
3. Wait, what is F?
And g at 3.
Isn't f at 3 7?
Wait, why are we finding it? Why are we
Okay, so which one's higher? The blue, right? Okay, so that's another way to see where they end up. Makes sense?
Yeah, but does the top and bottom rule apply
I'll
at the
show you one.
y-intercept
I'll show you.
or in the interval?
It's the entire interval.
So,
So if they cross and change, you have to do 2 separate integrals.
oh, that's stupid.
It's not stupid, it's
from
just the
like-
way it is.
So you would
I mean, it's not
split the
stupid.
boundaries by where they cross.
Okay, let's take care of this one, and then we'll move on to one where they intersect and you have to switch things. Okay? All right. So top is f of x, correct?
Yeah.
Okay, so that's what we're going to do. And you put them in the same integral, because it'll make your life easier in the end. So we have the integral from,
1 to 3.
and f of x is
Like x squared minus 4x plus 10.
minus
4x minus x squared.
do not please do not forget that subtraction is going to have to distribute. So you have f of x top minus bottom, right?
Why do you put them in one interval?
Because it's easier.
Okay.
You can do that. That's perfectly legal. It's not going to change anything in the answer. So would you rather do two separate ones or just one?
Just one.
Yeah, just one, right? So now we're going to combine like terms. What's x squared minus negative x squared?
2x squared, 2x squared.
And then negative 4x minus 4x.
Negative 8x.
Right. And the old loner, hanging out by himself, playing with his Nintendo Wii.
Hey, we
Okay, can you complete that now?
Yeah, on a good day.
On any day. Any given day. Okay, go ahead. It's on you. First one done that has work and a correct answer gets
Wait,
candy bar.
evaluated? Wait, do we have to evaluate it as well?
Get the final answer.
That's really unfortunate.
Is this an FRQ?
But no, has to be an answer. We simplify everything in class. And if you need help, that's the time back.
Oh, I know.
Oh. Oh.
Well, you really want that candy bar?
Really, yeah. No.
My brain is divided by that. That's my brain wants to say. Minus 8. And then what is exponent? It's 1 right now. What does it mean to you? Oh. Add 1. So, divide by 2.
Yeah, I was cheating.
You're just adding x to x. Yeah, this is x to the 3. That's the one now. And you evaluate 6. And then evaluate it to the bar. Yeah, the 8 times by 3 is 4. So now you plug 3 in there. Subtract 1 of them. Plug 3 in, subtract 1.
No, I'm
Just
not.
the answer. Is that the answer?
Everyone else is I
I'm gonna have to steal those Doritos.
You know.
11
No, I'm just gonna out loud.
What did you get?
213.325.
I'm closer.
You're way off.
I know I'm wrong, but I know I'm closer than that.
213.
You're a lot closer.
We start to really come check this.
I bet you
Check
don't
your
want my
answer,
confirmation.
Are you sure?
Yeah, I am.
100%.
So when you do the evaluate and you do like the integral f of b minus f of a, do you should distribute that negative to f of a?
Oh.
I always forget that. Do you distribute that negative? You know what I'm talking about?
Uh-huh.
So that
Here's
means-
your, if you're struggling,
Oh, I fixed it.
What'd you get?
That's 17.
Minus
It's pretty close. It's getting there. Kyra.
Area equals 5.34, and I have all the words to prove it.
Can you put that in a fraction?
You
Five
used
one
a calculator.
1/3.
5.1.
Yeah, she did use
Got
a
it.
calculator, we all did this by hand.
I used calculator.
Did I specify?
Ha!
No, I didn't.
Ha ha ha
But-
ha ha.
But you did say always.
You need to practice. So do it by hand. You guys, you're on the right track. So again, here's your integral. Power rule, right? Add 1, divide by that. And then if you're doing it by hand, this will be a by hand, no calculator problem on the test.
That's okay.
But we can leave it with just the 3
Not if it's multiple choice. So there's 3 plugged in, minus
2 over 3.
1 plugged in.
Oh, it's over 10.
Wait. Am I? Oh, it's because I'm dumb.
1, don't you feel dumb?
For some
2,
reason-
look at you.
Oh,
Thank you, Major Payne, for the giggles. That is 18.
What? Oh, yeah. I got it.
9 times 4 is 36.
Plus 30.
So I did the right thing with the wrong integral.
That's 4.
Plus 10.
Don't do that. That makes messy notes. So that's 12, right? -4 plus 10.
Number 6.
So 6 minus 2/3. 5 1/3. Or 16 over 3 if you're
Fraction.
That's just silly.
not a friend of mixed numbers. Okay, so work those through by hand when I give you classwork to do, because you need to practice, obviously. Okay?
I don't even know how it would work.
I don't either.
Well, no, 'cause when I went to the calculator, magically I
So, big idea, top minus bottom, you're good with that? Looks like, just keep working your integrals, keep practicing them.
This is like one thing that I
All right.
understand.
Here's the next challenge.
challenge comply.
Got it.
That's what it means.
Find the area between the graphs of these
Oh, no.
functions. What the? That's right, there's a, stop it.
Wait, did he mean to make that burger?
No, there's a pen sitting in here, and it was right on the board. Thing got confused. It's kind of like you guys sometimes.
Wow. Too many points makes things confusing.
We'll make this one a little easier on the functioning. There you go.
Wait, so f of x would still be top, right? -7 instead of -12.
That's the way it begins.
You have to evaluate at the 2 points.
So at the x-axis,
Intersects. This is gonna be a crisscross.
higher, right? This is the top,
Right.
okay? But do you know what happens at 5?
Oh, yeah,
These two are gonna cross,
guys
so
did bigger.
what's f at -2 and f at 5? 4 plus 10 is 14. 7?
So-
minus 20, negative 7 is 5.
Okay, and 5 is 25 minus 25 minus 7. And then g at -2, g at 5. Uh-oh. What does that mean? They intersect, right?
If
Do they intersect?
at the
Point,
end,
though, it doesn't matter, does it?
But it's a parabola and a line, right? If I have a parabola and a line, could they intersect in here? Yeah.
But that's outside of your.
How would I calculate that point of
Like that's what the
intersection?
graphs look like?
pretty much.
So if they're equal to each other.
Yeah, so this is the surefire way every time to get these intersection points, if there are any. So we can, if you want to do what we're going to do now, you can avoid this. All right. So x squared minus 5x minus 7 equals x minus 12. Set them equal to each other and solve.
Is that the valid thing, plugging in 3 and 4?
Oh, if you're that good, yeah. Most of us aren't that good. So, okay, move these to the left, and then factor. You're almost always going to get a factorable equation here. What are my factors? So x is 1 and 5. All right, so we already see that 5 is an intersection, right?
So since it's just an intersection, do you still have to do a second integral? Since that's where they intersect, or was it just because?
They switch spots.
But then that would just be from at 5.
Yeah, if you graph these two, looks like this. So we're doing this area here. So this is -2, this is 1, and this is 5.
So,
Right, so we have to do two separate integrals because they switch spots, right? So the first one is what?
Negative 1.
Yep. And it's f minus g, right?
Yeah.
Because the parabola is on top minus bottom.
G minus f is.
Okay.
so
So that's the first portion. That's this.
Plus integral from 1 to 5.
Okay. And then add from 1 to 5,
are you kind of,
top minus bottom. Okay. Like that. Or you look miserable.
hmm?
You look
Well,
miserable.
because, I don't know, I just got really confused.
Okay.
So, do you just always, like, first step to see what's top and bottom, do you always just find end behavior?
I thought you looked at that.
That's one way to do it.
Okay.
If you know that they don't cross.
Okay,
If you think they cross, then this is your best bet.
well, what else could you, like, do to see, like, what things would you look for to think if they cross to even, like, process if they cross. Does that make sense?
Yeah, it does.
What would you do to even?
Well, how would I recognize it that they cross
Yeah,
without doing a
justify-
bunch of work?
Yeah.
That's what you're asking.
Because like, I don't wanna find anything here.
You're fine.
That's just
I
something.
don't have any good advice on that one right away. You can always graph it. The book doesn't have any suggestions beyond what we've done either. So your options are to graph it or to calculate the intersection. Okay. These are obviously really easy with a calculator, right? So if it's calculator friendly, which a problem like this probably would be, because we don't want to take a whole bunch of time doing pre-calculus on a calc test. Like, we want to make sure you have that skill,
Yeah.
but we don't want to take up all the time for us to test you on calculus. So more than likely, this type of problem will be calculator friendly. And you'll be able to do the intersections or graph it really easily. Okay, so yeah. But I don't have any great advice on recognizing very easily if they intersect or not. Right off the top of my head. You can finish that, right? Good to go? Because I want to move to the next one where it has 3 curves in it. Right. The answer, if you're curious, it's all in your book. This problem's in your book. There's the answer. All right. So let's consider these 3 functions. Calculate the area of the region bounded by those 3 items.
Two curves, but they're open and good to the flat bottom y equals x. Y equals 3 cross off.
Pretty much. Yeah. So again, not knowing what this graphically looks like, how could we find the points of intersection of all 3 of those?
Make them all.
Right? So multiply, so we get 8 equals 8x cubed.
Divided by 8.
So 1 equals x cubed, and what's x? 1. Okay?
That means y equals 1.
X is 1.
Yeah, but it says right
So-
there y equals x.
So that means that it's a line.
This equation was not included in this.
Oh.
That's these 2. Y is 8 in this case. Right? If you want to calculate it, you can. You don't have to.
Isn't in this case y equals x?
Okay.
Came out bigger.
Now what?
He said the other 2 equal each other in the last set.
Now we set those 2 equal to each other. Right?
Multiply by
Multiply again. So what's x? 2, and that means y is equal to 2 as well. Right? And then what's the last possibility?
AX equals x.
And what's x?
4.
how to do this one.
Divide,
If I put 8 in, I get 64 equals 8.
X divide by
Nothing next to it.
So X is easiest answer ever. That means
Obviously
Yeah, I freeze when I see and the X's cancel. It's just confusing.
what's the y-intercept of each of those?
not. Zero.
There you go. All right. I'm not making fun of you. I'm sharing in your misery.
No, he's making fun of Lisa.
I'm encountering a depressing situation with humor. Okay, so if you want a picture of this,
I don't.
Well,
too bad,
yeah, but
so sad. It looks like this.
Holy cow. That's not really
Okay.
Oh, I get what the thing.
So 0, 0 is that intersection.
Right?
2, 2. It's right there. And 1/8.
So this is 3 intervals then? You're not having the fun time with the weights.
Can't even write a 1. Depressing. Okay. So therein determines top minus bottom. It's only 2 integrals still, because you still only have 2 regions to worry about. Right, so you have this
0 to 1.
0 to 1, and then you have 1 to 2. Okay. So what is the 0 to 1 integral? What's the top there? 8x. It's linear. And what's the bottom?
X.
And then what's this integral?
8 over x squared minus x.
From 1 to 2. Okay. So the setup on these is sometimes is what gets difficult. The nice thing about the AP exam, this is a very popular free response question. They usually give you the picture. Yeah. Yeah, they give you the picture, so it's very obvious what happens. Okay.
Why did you draw one?
Why did I split them?
Yeah.
Because that's where I have to write 2 different integrals. So see how this is one function and then this is another on top? They're different tops. The bottom remains the same, obviously, but the tops are different. So. Okay. That's about as hard as they'll get. Kendra.
So, when you're finding like tops and bottoms, especially because it's like two linears with a parabola, how do you decide like in that one where it makes like the triangle, the second one? Do you do it like by the points of intersection that are by it or like closest to it?
How do I determine top and bottom? Is
Yeah.
that what you're asking?
Yeah.
Okay. So we know the linear graphs intersect at 0, 0. 8x is steeper. That's the top, right?
Okay.
But then these two intersect higher.
Okay.
So 8 over x squared is going to be above x at that point.
Okay.
And then you can see the y value, it's lower. So you know top minus bottom there. Okay. Are we good? Do you have any questions?
We definitely should get a nose grade today.
Please?
How did you? Why? You just it's an expectation. If you don't take notes, then
Damon,
you
are you okay? What's wrong?
If he gets a nose grade, he's gonna stay up.
Wait, David.
Okay. Let me write this down. What section are we in? 6.1?
Yes, sir.
Here's 6.1b. We'll do this Friday, but just so you have it. And then the spiraling.
I'm gonna preemptively warn you and say that Miss Tutor is giving us the Great Gatsby novel, so expect
over the
less
weekend.
homeworks.
Okay, so this should be due Friday then.
No.
Yeah.
Thank you for the warning. So you have, this is what we did today.
Not 47, right?
47, yeah. We have 6.1 due Friday, or 6.2 already, so average value theorem, right?
Yeah.
Okay. You'll have some work tomorrow that will not be homework. Well,
6.1b, is that at 27 right before 55?
yeah, it is. Okay. This needs to be due Friday. We can do a check-in, and this will be due Tuesday.
So we're gonna check.
As much as I don't want to do that,
That's what we got.
Hey,
Hey,
well,
hey,
hey,
sir.
come back.
you got it?
No.
Okay, there you go.
Thank you.
Darn markers. Okay, so you have 2 assignments due Friday.
Did you ever turn off the
Is that 1, 2, and 9?
It's still on.
Mr. Arthur, for AP 3s out 1, 2, and 5.
1, 2, and 5.